Oh yeah, now it's on. When I'm rebuilding cars and doing stuff like that, I never count the cost of the tools because tools can be reused. And yeah, all of that. A box in a box. Think car. God almighty, that's heavy. Holy shnikes. That is stunningly heavy. Wow, oh my goodness, we got the silica packets everywhere. Look at that. Oh man, we got wiring harnesses, we got adapters, we got all sorts of stuff. I don't even know what half of this crap is, but I hope. Printer? Oh man, I hope this bad boy. Yeah. Gracious. Over there. There it is. Alright, that looks like a normal one. And we'll hopefully be able to connect to it somehow. But this is a bi-directional scan tool, which should assist me with troubleshooting and potentially, wow, that's heavy. Holy smoke, that's got some mass. This should help, not necessarily with diagnosis, but with programming an ECM or a PCM or other stuff. Wow, that's got to weigh 2.5, 3 pounds. That is impressive. Good night. Okay, all right, here it comes. Maybe. Ooh. Wow. That thing is a beast. Alright, well, we're not going to start this tonight, but we are going to charge it up, figure all that out, figure out how to log into it, figure out how to get it updated, and then tomorrow we're going to start trying to figure out that Canbus problem. And then we're going to go from there. I am going to fix this bloody Honda. Alright, well, after a couple of weeks of getting my butt handed to me by this thing, we're going to try to divide and conquer now. Got my new ThinkTool Pro S, which is actually bi-directional, so it can force the car to do things to test stuff, which has helped already. We'll go into that in a little bit. But right now, the airbag fault comes and goes. That one, depending on the day, that's the that's the increased resistance in that driver's airbag inflator. That comes and goes. So that's an intermittent. That may be related to some voltage. I'm not sure, because it could be, but I'm not going to concentrate on that one right now, because that one's not keeping me dead in the water. Obviously, the IMA system back here is unhappy. I believe at this point it's a bad inverter. I think it's going to need the full $1,800 treatment. I could get an inverter from Honda, but it's $1,500, and it only comes with a 1-year warranty, where if you buy the Green Tech unit like that already had in it, it's a 3-year warranty. So, for $1,800. That's probably where I'm going to go with that. But I've got other things going on too. I've got 2 other discrete problems, I believe. One of them is the Hydro Booster, you know, that 83-1 FCAN COM malfunction code. That's constant on everything. And the other weird one is this 0685 PCM internal circuit malfunction. That one I think is also discrete. And I don't think either of those are related, and I don't think either of those is related to the battery problem. I've run through the 685 troubleshooting. It says replace the PCM. I'm not going to do that yet until I get the rest of it going. The 83-1 troubleshooting is about 20 pages long. Lots of circuit testing, lots of resistance values, lots of voltage values, and it has a weird Honda special step. Jump SCS line with HDS. It's Honda Data System or something, or Honda Diagnostic System. Well, nothing I had could do that before. The Think tool can, and I think it's basically, if you didn't have it, you can go into the OBD2 connector and short the number 4 and number 9 pins to each other, which, okay, fine. But after you do that, then you start measuring resistances everywhere and checking for shorts and grounds and continuities and open wires and continuities and continuities and more continuities and more continuities and more continuities and more continuities. Basically, you're running through the entire FCAN system. And then you get to the MCM, do some internal resistance checking in there. And we got to check some ohms here on a connector on the PCM. We got more PCM stuff, all sorts of different resistances, and I believe that's really where it comes down to the communication. More resistances, gauge control modules, because that's where it goes, steering angle sensor, a lot of different stuff. And that's what we're going to run through today to see if I can figure out what has failed on this thing. Now, it's coming up in the Hydro Boost system, which does work. That funny looking thing with the little ball on it down there, that's the booster. But it's all related to the brakes, which is all right here in the anti-lock brake system. Now, I've done rudimentary tests with my other scan tool and even with this one, and I can see the booster coming on. I can see it building pressure properly. It's acting correctly. The brake system functions. But when I try to go into this new scan tool and do the unit operation tests, it can't do it. It fails immediately. It cannot communicate with that thing. So I believe that's my FCAN, the Canbus problem. So there's something wrong somewhere that is causing it to not communicate. It can talk to the module because it can pull codes. It can tell me there's a code. But when I go into the special functions and try to test it using the Honda special tests for different components, it can't do them. So something's going on there. I think this is a real code, but this is probably something that has been, this and the PCM issue, I believe, were there prior to the battery control system failing. Now, contactor-wise, we're getting back to that. I was able to, the other day, check the main contactor by going through its troubleshooting and disconnecting a bunch of wires and unplugging a bunch of stuff and then forcing 12 volts through a couple of these little wires up here, and I heard it. It clicked on, clicked off. I checked the continuity, as they said. When it was clicking on and off, it's perfect. The bypass contactor, which is the code that it's throwing now, that I've determined is what you hear when you first turn the car on. It clicks on, clicks off. And I was able to see that in the graph mode of this thing. When I turn the car on, you can watch it go on and then off again. So it is functioning as well. So either there is a resistance problem with it, which I haven't quite figured out how to check, or the inverter has failed and it's sensing a current or a voltage imbalance when it closes. So that's going to be my longer term stuff there. But for today, I'm going to be concentrating on this F-can issue. This is going to be real tedious. If I find something interesting, we will stop and I will show you what I find. I'm hoping I find something, because there's definitely a problem with this system. So we are about to get started, and if I find something interesting, I'll bring you along for the ride. Alright, well, the first test is to get the connector A off of the PCM, which I have, and I've gotten the cover off of it, which is that guy. I haven't broken anything yet, yay. And it's a little dirty, some crud, but you can see that really does look like a factory tape job. So I don't think this has ever been jacked with. The inside of the connector looks really good. Seal looks good. Little spider web, but nothing major. So we're going to start the testing. And this is what I was talking about. So SCS line is shorted, and now we can run this test as we're supposed to without worrying about whatever the hell the problem that causes if it isn't. So there we go. Alright, so the first part of this test, measure the resistance between test points 1 and 2. Test point 1, PCM connector A, number 3, white. Test point 2, PCM connector A, number 4, red. 3 and 4, that's on this side. And there, that's these two little guys there. And on the back side, it's the red and the white wire there. Question. Is there 45 to 58 ohms? No. There's not. What do you know? Okay. Alright. Disconnect the following connect. So, no. Go to step 2. So I'm going to write down, I had a pen, so basically we're at about 80 ohms. And now we're going to move on. So we already know, obviously from the code, but we know we do have a problem in that F-can. Huh, what do you know? Interesting. I'm going to double check my connections and make sure this is good, but yeah, there we go. Moving on. Yeah, sure enough, and I checked both sides of the connectors to make sure I wasn't stabbing something I shouldn't from the back. I checked just right here on these little tiny metal pieces, and sure enough, we've got around 80 ohms. So something is wrong there, and wow, that's going to be subtle, but we're going to find it. So now we got to go disconnect all sorts of stuff. Alright, so we have to disconnect the gauge control module, the VSA modulator, the steering angle sensor, the electric power steering control, servo unit, MCM, SRS, audio nav, TPMS, and forward collision warning, lane departure warning camera unit. Phew! And then we have to perform the same test again. Okay, now I gotta find all these bloody things. Yay. Holy Lord. That was vicious. Disconnecting all of those modules. This servo unit connector, which is the gray one down there. See if we can get some better light. Anyway, it's that connector there with the weird looking hooky thing on the bottom. Getting to that connector is the most miserable job since I've tried to do the spark plugs on the F-150 without taking the intake manifold off. That took forever. That was insane. However, I have literally ruined the car. Not really. But I have everything under the dash, in the dash, inside of the dash, behind the dash, disconnected, And the next step, and stuff over there, there's nothing electrical connected on this CAN bus right now, this F bus. I don't know if I'll be able to get it back together. I think I will. But the next check is, and funny, I've been watching the continuity here. I've been watching the resistance the whole time, and it's slowly been going up and up and up and up. Focus. Why are you not focusing? But it's slowly been going up and up and up. And then finally, when I got the last one unplugged, it went open. There is no continuity on those wires. So, no. Go to step 3. And now, we get to start checking all the individual modules and circuits to find out what's going on. I'm not looking forward to it. But the worst, I mean, none of them are terrible, except for that one down there near the brake booster. Let's see if we can get some better pictures of it now that I've unfocused this silly thing. It's insane. I mean, you can kind of see it down there. Sorry about the shadows. But it's down there behind, and the biggest issue is going to be this massive block of harnesses right there. I don't know how to take that off. If I'm going to have to do pinouts on that damn thing, holy smoke. I can't even see it, let alone get to it. So, it's going to be interesting. Anyway, that's what we're going to move on to now, is trying to check the rest of this craziness. Alright, so we have wrung out every wire, red and white, from the ECM to all of the modules. Every one of them is good, everyone is continuous, we have no breaks. So that's good. I don't have any shorts to ground, everything's good. Now what we're doing is individually testing the resistance values when we plug in individual connectors. So this is where it could get interesting. And what I'm thinking, if all of these resistance values come back, and my God, I hope the one back there does, correct, then that points to a PCM going along with that other code. But we're going to have to see. So I've got my 2 points. It's still open because everything is disconnected. It says reconnect VSA modulator control unit 22 pin connector. That's this bad boy down here. See if we can get this thing to go in. There she goes. Click. Measure the resistance. Is there 108 to 132 ohms? No, there is 2,500 ohms. Interesting. We're going to double check that. Interesting. So we're going to disconnect that quick and see what happens. And disconnect that again. See if she goes back to 0. And it sure does. Two and a half thousand ohms. Alright, well, we're going to continue checking all the rest of them, see if any of the other ones come up suspect. Alright, we may be on to something. The next one is reconnect the MCM connector, which I did. Is there 108 to 132 ohms? 127. Perfect. So that one checks out. That means I think I'm doing this right. So we're going to carry on. Alright, well, we got everything reconnected. It's not back together, but the only test that failed was the resistance check on this dumb thing. Now, it didn't have resistance checks for all the modules. I kind of wish it would have, but just those two, that one and the main one in the back. The main one in the back worked, but this one did not. So its solution is replace with a known good. I'm going to see how much that's going to cost. Maybe I can find one out of a junkyard. We'll see. But that should be entertaining. I'm wondering if I have to break those lines to get it out of there. I kind of hope not. Unless it's this whole thing, it doesn't just come off of the back computer. Oh well, we'll see. But that is kind of related to the boost. It's the ABS, the VSA module. But that's one of the things that code, that 83 code does say, is VSA module failure could throw it. So we will see if that's it. But that's probably going to be it for today. I'm tired. Not quite aggravated, but close. I've got a mess. I got to try to remember how to reassemble. And I think it's time for a break. So that's it for today. We'll talk to y'all later.